All right. So I've got SOLIDWORKS open. If you're waiting for SOLIDWORKS to open, probably just watch this first part. And the first thing we're going to look at is this Better Involute gear set that I have. And I want to show you all that just to make a few points before we move on to creating our own assembly using the parts from the robot.zip folder. So inside here, again, you can follow if you want to. If you don't have it open, I'm not going to be collecting this file as part of the week progress submissions. I'm going to open the gear assembly. I made a much larger tooth profile on this one, but this is derived from a very similar set to the one we did in class earlier. The biggest difference is that this one has a much larger dedendum, a larger pitch, and the base circle is appropriate for both of these gear sets. I probably need to rebuild this to get to size it appropriately. So I'm just going to hit rebuild on the top of the screen. And you can see that these are here. This is the contact circles. They're touching there. Right now, I have a gear mate based off of the size of the contact circles. And since we're rounding on this one, it doesn't work out exactly right. But you can see that the gears are moving reasonably well. What I want to show you here is that I can actually have SOLIDWORKS calculate the motions based off of the contacts using the move options with physical contacts turned on inside SOLIDWORKS. So to do that, all I need to do is first make sure that I don't have any intersecting geometry inside the assembly. And generally, when you're starting off doing any kind of motion analysis, either using the mates or using a motion study, you want to make sure that you don't have any interferences in the assembly. So that's the first thing I'm going to check. I'm going to go into evaluate, interference detection, click calculate, no interferences, then I'm good. I can make this have some interferences if I kind of drag this down so that way the gears are not meshing. Check for interferences. It will show you where the interferences are and how big they are. But if you have any interferences in your assembly, then most of the things that we're going to talk about today will not work. So just going to pause for a few seconds to see if any of you have questions on the interference thing. They can fit perfectly, so you don't have to have clearances per se. You just can't have any overlapping geometries. So I'm going to roll this back so that my gears are not interfering with each other. Then I'm going to do the interference detection one more time just to make sure I got no interferences. And then what I'm going to do is I'm actually going to turn off this gear mate. So I'm going to suppress it. Now the gears will move independent of each other. And what I can do is if I go into my assembly options, and rather than just dragging with using the mouse, I click on this move component option. And then on the right here, you see these options for standard drag, collision detection, and physical dynamics. If you want parts to move as a result of a collision, then you want to turn on this physical dynamics. So if I turn this on, and then I drag the gear, you'll notice that the other gear moves as a result of the collision. And I can actually use this to see the contact point shift over time on my gear set. You can kind of see the contact roll along this. Now, this is not, it looks like a series of segments here on the display, just because the way it's rendering the curve. So it's not showing the, I guess, fully rendered curve profile as driven by the equations in the gear. So when it tries to render a circle, it doesn't actually render a circle, it renders a series of lines. And so it doesn't line up exactly perfect on here, but you can kind of see the transitions as it goes across. And I'm always catching a new tooth at the top and then kind of releasing the last tooth at the bottom. And it doesn't matter what I do here as I roll it around. If I ever come back into my evaluate and do interference detection, I'm going to get no interferences. Because what it's doing is it's looking for whenever there's an overlap. And if there's an overlap, it pushes that next component out of the way in whatever directions it's allowed to rotate. You get the same options in the rotate options. So if I go to move, rotate, I wait for SOLIDWORKS to respond. Hopefully it's not crashed. But it's the same exact components that we have here. We can go to physical dynamics and we can rotate. Oh, I must have accidentally moved it while I was collating or something. Let me evaluate interference detection. Yeah. I must have just accidentally clicked it while it was frozen. Should I adjust it a little bit? No, so close. I don't have a whole lot of clearance in here. No. Look at that bad position. I'm not going to do this one more time. You guys already saw it work. All right. I got it to work. I moved my gears. They're not on the right spot anymore, but you get the idea. As long as I'm able to set up the assembly so that way I'm not starting in an overlapping condition and I have things that will move appropriately based off of collisions between objects. You don't have to specify the mates. You just have to go into the move options here and then specify you want the specific type of collision. You can also look at the conventional collision detection. This is helpful for figuring out kind of where the limits of things are. So I can drag things around and it'll stop when it hits a collision if I can get it to start in a non-colliding state. See if I get. Oh, I got to turn my collision. It's ignoring these ones because it's already collided with those faces. So you can see all the faces that are lighting up. Those are the ones that it's colliding with. There we go. Now I'm not colliding. Stop at position and make a sound. Bonk. And one of the things that's interesting there is you'll note that it actually collided on these faces at the same time because this gear is really set up as an involute gear. And so it's able to maintain contact across multiple teeth at the same time, which is good. There is kind of a boundary on this in terms of the, what amount of overlap is considered to be like a collision, not a collision, which you can adjust on these sliders. So there's the sensitivity thing here. I wouldn't adjust that too much. If you make it too far towards max or too far towards min, either it takes a really long time for it to run or it starts ignoring things. But you can adjust it in small amounts if you find that you need a little bit tighter control on your sizes, or it's being a little bit too sensitive and not letting you do what you need. And you can also isolate and only look for collisions on parts that you're touching as opposed to all the parts if you want to look at downstream or not downstream effects. Any questions on doing the collision detection or the physical dynamics using the move options in an assembly? I hear ding, which is good. You guys are playing with the collision detection. Right. Next thing we're gonna do is we're gonna build out an assembly. And I wanna show you guys some assembly features you may or may not have seen in the past. And then I'll show you how we can actually move a fairly complicated set of parts in very specific ways using just mates. And after that, we'll look at doing some motion analysis. Hopefully we'll have time to do that in some level of detail. So go ahead and close out the gear assembly if you haven't already done that. I don't need to save it. I'm going to do a new assembly. I'm actually going to work in millimeter gram second, but I do want to work from my base. These are all from the robot.zip file on Canvas. So I'm going to open my base. I'm going to click on the green check mark. And I'm going to change this from MMGS to IPS. I'm just going to flip it so it's not upside down. Yeah, I made inch pound second. I made all the robot parts in inch pound second. Once I've got that first part in, I'm just going to drag in the rest of my parts. So I'm going to go into the zip folder, or not the zip folder, the uncompressed folder here for week 4. And I'm just going to drag in the rotator, arm 2, spoon, and ball. Those are all my parts. So once I've got that, I'll minimize that and I'll maximize my screen. The first mate I'm going to use is actually a hinge mate. The hinge mate is just like using a concentric and a coincident mate, except for it combines them into one utility, which can make your model tree more concise. So if you go into mate, actually, does someone need a few more seconds to get these parts loaded in? So what we're gonna do is we're gonna build out a little robot arm here. It's only got a few components. It's gonna have a set of degrees of freedom, and we'll actually have the robot move along the path that I have specified inside this base after we have it. And if we have time, we'll also have it go and drop a ball onto this rolling track and then pick it up off the bottom and then bring it back up and drop it. I don't know if we'll get to all the way through that or not, but hopefully we'll get at least most of the way through it. So far, so good. Who still needs time to get the robot parts loaded into an assembly? 1, 2. Anyone have any questions while we're waiting for them to get stuff loaded? Marza? Yeah, just flip your screen. Marza? Parts? So I put mine upside down and then just flip my view. I just built the base upside down. The top is the bottom and the bottom is the top. But it doesn't matter for the purposes of our assembly. So I'm not concerned by that. Anyone else have questions while we're waiting for this to load in? Close that. You don't need to have it open. Anyone else having issues getting those loaded in? Other questions on there? Again, I'm going to do this one more time just to review. Let's start over. I'm just going into a new assembly. For the first part in the assembly, I want to click on the base, click open. I don't want to click on the workspace because I really just want to make sure that that thing starts off with the origins aligned. Most of the time, if you're working on like a CSWA, CSWP style question, you're going to want to have some base component or starting component or whatever that has the front right top planes of the assembly align with the front right top planes of the part, and that will do that. And then the rest of them, since I'm going to position them using mates, I don't really care where they are, so I'm just going to drag them in. You can drag in multiple parts at the same time. So I can drag in all 4 of those at once. I don't typically do that because sometimes that makes SOLIDWORKS crash, and I'm just being conservative. All right, now I'm going to start adding my mates to position these. Again, I'm going to start with my hinge mate, which you may or may not have used. Most of the mates in SOLIDWORKS, if you read what it's asking for, you can figure out what you need to do to make that mate. So I want a hinge, which is in my mechanical mates. You see it's right here, it says hinge. So I'm in the mate tool, in mechanical, click on hinge. It says, what are the concentric selections? So I want this hole to be concentric with this hole. What are the coincident selections? I want the bottom of the rotator to be coincident with the top of my base. Again, pretty simple set of mates, right? I hope. And again, not that hard to interpret based off what I was given. Again, I hope. And the advantage there is I've added what is equivalent to a coincident mate and a concentric mate without having to go through and do an extra click. So this is really all about saving you time when making assemblies. Another really helpful mate is the width mate, which I can click on this face and this face to get the concentric mate. I'll go into my standards. Wait for SOLIDWORKS to respond. I need a new computer for up here. Or maybe not. It slows me down. Makes it easy for you guys to keep up. And then click on concentric. And I want you guys to also realize that I can click on the faces and then the mate, or I can click on the mate and then the faces. The order is up to me. Most of the time, if you know what kind of mate you want to add, it will restrict your selections based off of what you click. So a lot of times it's good to click the mate first. Another mate that I like to use a lot is the width mate. This prompts me to click the width selections and the tab selections and lets you know right now it doesn't matter which one is which. So if I click on these two surfaces as my width and these two surfaces as my tab, it's going to center that part. If I flop those and I go into the width mate and I select these two surfaces as my width and these two surfaces as my tab, it does the exact same thing. So don't worry about which one is the tab and which one is the width. Two sides of one object, two sides of another object gives you what you need. So again, I'm going to go into advanced mates. So in the mates tool under the advanced tab is the third one down. Also remember, if you guys don't remember where something is, go into your commands. Oh, it doesn't come up. Well, I can always search. So go to my help. There's a width mates right there. No thanks. Again, the help options are very useful in understanding some of the limitations of the different parts as well. One of the things that we're going to see here in a minute that is limitation of the width mate is that I think it will not work inside of our motion analysis. So, yeah, Marza. The hinge?
Yeah.
Yeah. What about it?
Which one of the mechanical did you use?
Yeah, so the first one I did was the hinge mate. And again, inside the hinge mate, I have two concentric selections, the two circles that I want to line up with each other. And then two coincident surfaces, the two flat surfaces that kind of abut each other to make the hinge.
Next one.
What next one?
I think you did another one for the.
I did a concentric to make the center axis of this so it rotates around, which is this concentric mate right here. And then I did the width to hold the in position. That keeps that gap constant on both sides. And that'll adjust. If I change the size of one of these parts to make it fit that gap, it will still stay in the middle, right? And right now it's not checking for interferences or anything, so this goes wherever it needs to go. If you're smart about how you make your parts, you can get the same kind of constraints without having to use these fancy tools. So in both of these parts, I'm going to turn on my reference plane view. So I'm going to go into my little eye here and turn on the primary planes. You can see that I have a front plane going through the middle of the arm. And then on this part here, arm one, this thing is arm one. Let's turn on its view. I can see I also have a very similar front plane going through that arm. I can also use those for my mates. So don't discount the use of reference geometry to align your parts, especially when you're looking at like angles between different faces. A lot of times having the angle between like the center of a part and the center of another part is more valuable than having like the side of the parts. So I'm going to show you guys what that looks like right here. I'm going to do a mate between this base here of this arm and this base here. I'm just going to make this concentric, just so the pins line up. But then I'm also going to use the front plane of this arm 2 and the front plane of arm 1, which honestly, I kind of hate selecting those outside of the view space right here. I wouldn't normally do that. I'd open up a little drop down menu here. I go to my arm 1. I select the front plane there. Makes it a lot easier to make sure I'm getting the thing that I want. And then I would go into my arm 2 and select the front plane from there. And I can just make sure I'm not accidentally clicking the wrong thing. The other advantage is I don't have to have these planes showing on my parts to be able to do that. And so I don't have as much clutter on my view display. Oh, I didn't mean to add an extra mate there. So I can go through and turn off all these views. I don't have to see those mates, those reference planes all the time. The questions on adding mates from reference planes, probably review for most of you there. The what mate? Yeah, sure. I'm just going to suppress this one. Again, I can use the with mate here as well, right? So I can go into mates and I can go into my advanced, click on width. I'm just taking 2 sides of one object and 2 sides of another object. It doesn't even need to be the inside sides, right? I can do the outside to the outside, outside, there we go, outside. Same thing, because it just makes them equally spaced. Now that wouldn't work if I had one side that was much thicker than the other side, right? But as long as it's symmetric, it's fine.
You were doing the
I made the planes coincident. Yeah. Which if I just click on the 2 planes, that's going to be the default. Funness, right? So far, so good? All right. I'm going to go and add another mate so I can position my spoon here. On this one, I'm going to pay a little bit more attention to how I have it set up because there is a cup on one side of the spoon and not the other. So I'm actually going to set the orientation of the spoon first. I want to make sure that the cup side is up. So I'm going to mate the top of the cup with the top plane of my assembly. And I'm going to make sure that that's facing up. Keep in mind with all these mates, I can flip them however I want. And I don't have to take the default. The default is coincident. I don't actually want that to stay on there. I just want it to always face up. So if I just want it to always face up, parallel is the same thing as coincident, except for it allows for whatever distance I want. And if I wanted to, I could also say like, I want it to be a certain distance up off the ground or whatever. In this case, I just want to make sure it always stays facing up. And again, in this case, I have the cup side is facing up all the time. So now wherever I put this, I can drag it all around the place. It's always going to face upwards. Yeah, I can do it again. I would be glad to do it again. Did I actually get it undone? Yeah. So I'm just going to click on the top of the cup, the top of the flat face here. So not the actual bold part. And then I'm going to use my top plane. I could also use any of these flat surfaces on my base. They're all going to be parallel with the top plane, so it doesn't really matter. But I'm going to do parallel with the top plane. Then I'm just going to look at it and I'm going to make sure that if it's facing down, just flip it. So there is facing down, facing up. And you can use I'm using the middle mouse button to rotate my view, to kind of look around. And I'm using the mouse wheel to zoom out. So scrolling up, it zooms out, and scrolling down, zooms in. And then I click on the green check mark to accept that mate once I have it in place. Keep in mind the mate tool stays open because it assumes that when you're adding mates, you probably want to add more mates. So once you're done, you want to click on either the X or the green check. The only difference between those two is that if you have a partially selected one, it will accept it. If you have a non-partially selected one, it will reject it, right? It doesn't really matter if you have all the ones you want set up. I also want to make this hole on my spoon concentric with this hole on my arm. And I'm going to use the central plane for my spoon just to show you that one more time as well. So I'm going to use the front plane on my spoon, and I'll make that coincident with the front plane on arm 2. A lot of times, if you have the option of using the basic mates as opposed to the advanced mates have kind of a higher probability of over constraining the assembly than the simple mates. So if you have the choice between a simple mate or an advanced mate, most of the time you probably want to pick the simple mates, the basic ones. But you may say, like, look, I don't know how to position this so that way it's the same on both sides. Well, then you want to use one of the advanced, symmetric or width. By the way, symmetric and the width is the same, except for on the symmetric, you have a central plane that you're making things symmetric about, whereas the width, you have a gap that you're trying to keep it symmetric about. Look good? Got a nice little robot arm here. Whee! If I want this robot to follow a specific path, what I can do is I can specify the path that I want it to follow, and then add a mate on that path. It's called a path mate, which is one of our advanced mates. I actually have a path built into, I'm gonna have my ball too, sorry. I'm gonna make my ball coincident or concentric with the cup on the spoon. There we go. I forgot the ball. Sorry about that. It doesn't really matter, but I like having it. I also have a point here at the middle of the hole on the spoon, just as a reference, so I can keep that on the path. It helps to set up the path mate. Right now I can't see my path because I don't have the options showing that spline. So I'm going to turn on the view to view curves on my base. So if I click on base, which I can do in the workspace here, or I can do it in the model tree here, click on my view options, turn curves on. You just kind of see how I can toggle that on and off. Turn that on. Then what I want to do is I want to make my robot follow the path of this curve with the ball, really with this spoon, but it's at the center of the ball as well, since they have a common center. I'm gonna do that a little bit slower. I want to make sure everyone has that path shown before I move on. All good? All right. So I'm gonna go back into mates. Oh, nope, not insert component. Wrong button. Back into mates. Go to my advanced, and I'm gonna click on path mate. I'm gonna start with free, and then I'm gonna show you guys what some of the other constraints on here allow me to do. So the path constraint, you use free, all good. The component vertex is the point at the top of this kind of the center of the ball above the spoon. The path selection is the curve, and that is actually in the base part. So edge at base 1. And then I'm going to leave these as the default for now. We're going to come back into this into a minute. So I'm going to accept that. And now what you should be able to see is that I can actually move my robot around and it will follow that path. And so when I talk about making a series of mates that accomplishes, a complex movements, that's kind of what I'm talking about. Notice here that it does want to kind of elbow down and get weird there because it's trying to solve the inverse kinematics, and it's hard for it to interpret what I want. If I click this from the top, it's a little bit easier for it to tell which way I'm trying to get it to rotate. Fun, right? Yeah, the center of the ball is the point the path's following. So to get the curve to show, click on the base. The curve is actually in the base part. And then on the little eyeball, there's the option to show or hide curves. So if you toggle that, it should show up. Again, it's in the base. So make sure you have the base selected when you toggle that button. Just like we did for the reference planes, it will show or hide those for the individual parts if you have a part selected. That solve it for you, Eduardo? Or... All right, Pedro. Everyone got that working? Yeah. Another nice thing about this, if you want to do this, use this for analysis, is I can explicitly specify how far along that path or what percentage of the distance along that path that I want it to have. So I can go into my path mate. I'm just going to right click on it, do edit feature. And I can change this from free to either distance or percentage. I like percentage better because I don't know how long that spiral is. So I'm gonna do percentage along path. And it starts at whatever the start of the curve is. And you can see I can tick this up and it moves it along that path. So I can put it wherever I want from 0 to 100%. I don't know why this one specifically, it doesn't actually go to 100%. It stops a little bit shy. And I found that if I do 99.9%, it actually goes further. I think it's a rounding error because it's calculating how long that path is and then translating the percentage into a distance. And it's just making a rounding difference. So I don't know why it does that, but it's kind of weird about that. It works though. So this is inside editing the pathmate. So if I right click on pathmate and then do edit feature, I can change this from free to % along path. Then I can specify how far along the curve do I want that to go. Which is, again, we're using the mates to drive the assembly in complex ways, which we can use to analyze the parts or just for fun. This is just kind of for fun, right? But if I had a robot and I wanted it to move along a certain path, then I could use that, right? We can also use the analysis tool to look at different mates and get outputs here. Another convenient way of getting outputs is I can actually use my sketches in the assembly to look at angles between parts. So on here, what I want to do is if I look at the angle between arm 1 and arm 2, I'm going to look at the top plane of arm 1 and the top plane of arm 2, and then click on Smart Dimension. I can place the dimension between those planes. I didn't move it. Like it didn't give me the one I wanted. I'm gonna click on the, I'm gonna exit that. I'm gonna do Smart Dimension. I'm gonna show my reference planes. You know what, let's just, I gotta click on each of these. Oh, you know what, I probably do Smart Dimension and then go here. My arm 1 top plane, my arm 2 top plane. I should be able to click to place it. Why is it putting it over there though? I don't like that. You know what, I'm gonna be lazy. I'm gonna turn off the views here. And I'll just get the angle between the 2 top surfaces. So I'll just do Smart Dimension from this surface to this surface. I want you to give me the dimension right here. That's how it works. Oh, I get that angle there. I can do the math to figure out what this angle here is. Usually it lets you click where you want the angle to be. Then that allows you to specify if you want like the obtuse or the acute. Yeah, like this. So it should be letting me pick which side I want the angle to be on. So I know which one I get. Now those dimensions that I have here using the Smart Dimension tool, I can't use those to define the angle of the arm. So that is purely an output. But again, as I move this along, it will recalculate and give me whatever that angle is. And so if I wanted to figure out, you know, what the range of angles I needed to do to get the sizes I want, I could do that. It's not displaying them very intuitively because of the way I have them pushed, but you can kind of see that as I move around, the angles are updating. Yours is like going off the screen or something. It could be the view options that you have. Maybe you have it set to not display dimensions. So one of these options should be dimensions. I think it's this one here, sketch dimensions. Maybe under annotations for Dim Expert. View sketches. Oh, I tried turning my annotations off and it froze. Did I try this box right here? It's labeled as top level annotations. Is that on for you? It's a little assembly box with ABC on it. Yeah. I'm not a big fan of these, but they do work. The problem is they just don't tend to render in convenient places, which I don't really like. You can also just use the evaluate tool and measure the distances. The disadvantage with that is it doesn't stay on the screen, right? So there's the angle there. So it doesn't really like doing this a whole bunch because it wants to put the dimensions in a specific plane based off where you click it. And then when you rotate it around, it's like, where do I put the dimension now, right? It gets confused. But it does give you the right values. It's just like where it's being shown is oftentimes somewhat unintuitive. Questions on that? All right. I'm actually going to save this assembly. I'm just going to call it path driven. And this one allows for a free rotation. One of the things I like to do when I start working in a motion study is I like to back up my assembly first, because a lot of times the set of mates that you need to use to make the motion analysis work are not necessarily the same mates that you want if you're trying to do an analysis based off of the combination of the mates. You're going to end up having to suppress and unsuppress mates to make the motion analysis work. And most of the time I find myself wanting to have a backup of my original assembly that doesn't have a weird set of mates that are configured just for the motion analysis. So I'm going to save as again. Oop. I'm just going to say real build and save. And I'm just going to say motion driven. And now if whatever I changed I do to this one, I don't have to worry about it messing up my first one, which was kind of moving the way I wanted it to, where when I moved the arm, it rotated around. Does that sound okay to everybody? Okay, yeah. Sounds good to me. You guys may also note that this arm occasionally flips down, kind of past where I want it to be, especially if I try and drag it from the arm itself. If you want to, you can restrict that by adding a limit mate. So I'm going to go into assembly mates just to show you where this is. You don't need to follow along with that. In advanced here, you have these ranges. So there's a distance range and an angle range. If I click on that one, I can click on this surface and this surface, and I can say that, hey, I want that angle to be no less than, let's say, -10 degrees and no more than 89 degrees. Try flipping the alignment. If it's saying that that limit is going to break as another mate, then chances are I have the alignment backwards. Okay, that one worked. So now it shouldn't allow it to totally flip. Although I may have overdefined the assembly. It looks like I overdefined it. Oh, I put the minimum in the wrong spot. No, that should be the minimum. You know what? Let me turn off my path mate. Suppress that. Now this can rotate. I'm going to add a limit mate. That could be it. It could be just because that angle is set by the other configuration. And so there was no reason to have a limit mate there. Let's say -10 to 80. Yeah, I have it in the wrong direction. It's okay. I have it backed up. Let me rotate that. Giving more trouble than I thought it was worth. Opposite faces. Okay, good, good, good. Minimum. Let's just do 10 to 80. Maybe the negative is confusing it. There you go. So it hits a limit there. Oh, I'm getting too close to the edges. It's flopping. So you can, there's the 10. If I pull it too far, it goes to -10. So it's flipping on those axes. But you can see that it does hit a limit on the top. You gotta be careful with how you define these because they're kind of sensitive. Anyways, don't add the limit mate, but you can add limit mates if you want to. They work reasonably well when the other positions of the assembly are not going to push past those limits too easily. So if I can specify, a distance dimension between 5 and 6, and the assembly doesn't break if I go from 4 to 10, then it's going to work better. If you have things that break the assembly when you go past the limits, it's not going to work as good. So you may have to add more mates, more constraint to it to get that to work. All right, so I'm back here. I don't have my angle mates. This thing is still working fine. I'm going to turn on SOLIDWORKS Motion. So go into SOLIDWORKS add-ins, turn on motion. I realize that it's 9:15 or 4:15, so we're almost out of time. And then once I have that on, what I can do is I can go into the motion study. It's going to complain to me about using the free mate on the path. I'm just going to ignore it. I don't think it's going to give me any errors. Yeah, so we're good. It's ignoring my coincident mate inside this arm, but I'm not sure that I care about that either. It seems to be running okay. So I'm just going to leave that as it is. And one of the things that we didn't cover in the design for manufacturing class, but I think is very helpful, is driving assemblies with servos. So what I can do inside the motion analysis is I can define motors for all of these parts. And I actually want to start this at the top of the curve. That's going to be my starting position. Try to get a good orientation that I like. There we go. That's good. I'm going to update my orientation camera, just doing replace key. So that's my default orientation. So when I watch it, it'll go from there. And I'm going to add a motor. I'm going to click on the cylindrical surface of my base. It's going to automatically default to a rotary motor because I clicked on a circular surface. And then down here, rather than running this as a constant speed, I'm going to change this down to servo. Now, if you're doing this using the time slider on the bottom, like we did in design for manufacturing, then specifying these other options probably works better. The servo works good using the key events sequence that I'm going to show you guys in a second. So click on servo and then set this to position, or sorry, displacement. Displacement, position, same thing. So I have a, cancel, I didn't want to change that. Okay, save it. I have a rotary using that face on the base of my rotor, using a servo with displacement. And click on the green check mark. And then what I want to do is, rather than controlling the movement of the motor using the positions on the slider here, I'll explicitly tell the motor how far I want it to move using event-based setups. So I'm gonna click on the event-based motion view on the right-hand side of the screen. If you don't see that, make sure you're in motion analysis. If you don't see motion analysis, make sure you have the SOLIDWORKS motion tool turned on. Click on that dude there. You have this option, and now instead of having a time slider, what I have is a sequence of tasks that I can set up just like an animation playing in PowerPoint or something. And then on the right, it'll show me how long it takes for that sequence to actually go through and finish. So I'm going to add a task. And what I'm going to do is I want this task, this is called task 1. I'm going to rename it. Rotate base, if it'll let me. Nope. That's the name of the task. I can change these sliders to make it however I want. The trigger here is just time. I don't want it to wait 5 seconds. I'm just going to have it start at 0. And then the thing I want it to move is my rotary motor 1. Everybody see that? I'll click on OK. The action, I want to change the value, which is going to be the displacement of my rotary motor 1. And then on here, I can say, what do I want to change it to? I'm going to move it to, let's say 180 degrees. You notice the units are actually in there too. If you see the wrong units, you probably just set up the motor wrong. And then you guys specify how long you want it to take. You don't want to move 180 degrees in 0 seconds, guaranteed. So it's going to have to take some time. And if you make the movement steps too drastic, SOLIDWORKS will actually crash because it'll say like you need infinite force to achieve that motion. So make sure you're giving yourself time for these events to happen. So I'm gonna say 5 seconds. And then on the profile here, I don't want it to be linear because it has to go from having no velocity to a certain velocity in 0 time. That's no good. Usually constant acceleration or cubic work well. Those are both gonna give me S curves. Constant acceleration is good. That will give you actually the minimum amount of force needed because it's going to accelerate all the whole time and then decelerate the whole time. So that's minimum torque. So again, I'm using the name of the task as rotating base. I just changed that. For the feature? Over the profile? Oh, I use constant acceleration. Yeah. So constant acceleration or cubic will both work good. And then what I'm going to do is I'm going to calculate. And we should see this thing go. Oh, wait. I'm going to hide this for a second. No, I've got 4 seconds. Well, maybe I'm going the wrong way. Yeah, it needs to follow the path. If I try and go the wrong way on the path, it's not going to go. Start 0 seconds and 5 seconds. Rotary motor. Why aren't you going? I'm gonna try a smaller angle here. Let's just try 10. -10. Why are you not going? Oh no, I've just got my limit on there still. Why are you there? Bad limit. Delete. Yes. I'm just gonna make sure this still moves. I set myself up for failure by not checking to make sure I had that limit moved out of the way first. Calculate. There we go. Yeah, so it doesn't need to be negative. My problem is I still had that limit on there. So I'll do negative 180, I calculate again. You see it slowly speeds up. My mates are all messed up because I had that limit mate. And so when I brought it in here, it suppressed my other mates. And so now it's not holding those. But you can see it is trying to move that through the path, it's just it's falling apart instead of keeping it together. We are out of time. I'll probably make a video showing up how to use these. It's not terribly difficult. Really what you do is you add motors for every motion you want to occur. And then you add tasks for every movement you want to do. The tasks can be based off of time. They can be based off of other tasks. So you can do after the previous task, you do after the previous task with the delay. And you can also make them be based off events. So you can define events using sensors inside here. And then most of the time, the sensors are going to be like a certain distance, right? So proximity, when a ball gets to a certain position or when a actuator gets to a certain position, you stop or move or do something else, okay? Again, if you want to use those or any of those for your mini project, you can let me know, we can work through them. I'll make a little video. I'll get this thing working properly. Then I'll describe you guys all the different steps that I used to make it drop the ball and move it around. Sound good? What's that? For this one here? So for the rotary motor, all I did was click on the motor tool and then clicked on the cylindrical face of my, it's called a rotor, that's the first part. And it automatically selects your rotary motor as the type based off the selection. Oh, constant speed, servo. So whenever you're going to drive things from the task list, you want to use the servo type because it'll let you specify inside the task what the speed is. All these other ones are going to specify the motion as part of the motor, right? So if you want to decouple the movement and the object, you want to use servo, right? You mean, think about it, servo is like direct control. Everything else is just like an obstacle. But sometimes you want to just have like a motor that produces a certain amount of torque or that spins at a certain speed. And you don't want to have to specify that, you just turn it on and off, which you can do. And you can do that inside the task as well. So if you have a motor that say generated 10 horsepower, you just wanted to generate 10 horsepower, you could choose the task and say turn it on, turn it off. You just wouldn't be able to specify what its position was, right? You can also change this to velocity or acceleration if you want it to do something like that. Mine flew apart. Another thing you can do is that if you do mess up your mates in your motion study, just make a new motion study. A lot of times that will help fix problems because then you're starting off from like a more on scratch basis. I find that usually I got to make a motion study a couple of times to get it to work the way I want it to. Especially something like this where I have multiple configurations, like somehow this got on the outside of the ball. I don't know how that happened, but it did. And now fixing that inside the motion tool is hard. I don't want to do it. I want to get into a better starting position and then go through and fix it. All right, so for your week 3 progress, I do want to see the assembly of the arm with the ball following the path. You should have at least one motor moving that assembly through one step. You can get credit for that. If you do want to go through and revise that part to make it so the arm drops the ball, spins around, catches it, spins back up, drops it again, you can set that up. It's quite a bit of work. You may have to modify the parts. You need like a funnel at the top, basically. Or you might need a funnel at the top or the bottom to kind of hold it in place. Then you can do that for extra credit. I would probably suggest that don't do the extra credit portion of that until after you've finished your mini project. But if you want to mess around with motion mates and stuff like that and get that to work, then good on you. All good? All right. Thanks for coming, everybody. I'll see you all in class on Friday.